Okay, 5.5, derivative of y equals tan x. So this is another trigonometric ratio which we need to know the derivative of. Y equals tan x. We're actually going to derive this. The reason why we're going to derive this is I'm going to show you how tan x became, the derivative of tan x became what it is. It is quite sneaky. Alright, y equals tan x can be written as y equals sine x over cos x. How do we know this? Well, we know this through the quotient identity. From that, we can find the derivative of this using the quotient law. Using the quotient law. So, derivative of sine x over cos x is equal to cos x times cos x minus negative sine x times sine x. On the bottom will be cos squared x. Well, we need to simplify the numerator. We get cos squared x plus sine squared x all over cos squared x. Well, if you remember what identity it is in the numerator, you'll notice that the numerator becomes 1. 1 over cos squared x because of the Pythagorean identity. Finally, y prime is equal to secant squared x because of the reciprocal identity. And it's funny how we use all three identities to prove the derivative of tan x is equal to secant squared x. So you don't need to be able to prove this all the way down here, folks. You just need to be able to tell me that once you have tan x, you know that the derivative of tan x is actually secant squared x. All right, let's go through some examples. Before we do that, let's talk about the derivative of tan of a function. Well, the derivative of that is going to equal f prime of x times secant squared of that function. That is the derivative you need to know, folks. Example, determine dy by dx. Y is equal to tan of 5x squared minus 2x. What is that derivative? Well, dy by dx is equal to, in brackets, 10x minus 2 times secant squared, because that is the derivative of tan. The derivative of tan is secant squared of the function 5x squared minus 2x. The function remains the same when we're taking the derivative of tan, sine, or cos. All right. Next, y is equal to 3 sine x plus tan x all cubed. Let's find that derivative. Well, dy by dx is equal to 3 times the derivative of the inside, which is 3 cos x plus secant squared x times 3 sine x plus tan x all squared. The reason why is that we take the 3 to the front, that's where this came from. Take the derivative of the inside, that's where this came from. And then we multiply the inside times the inside with 1 less power squared. And you don't need to simplify that any further. In fact, it would become more complicated more quicker. So we just leave that. Let's find the next one. Y is equal to 3x squared plus 2x times tan of 5x plus 2. What do we do here? Well, that would be the product rule. So, take the derivative of the first, 6x plus 2, times the second, tan of 5x plus 2, and we add the first, which is 3x squared plus 2x, times the derivative of the second, which is 5 times secant squared of 5x plus 2. From here, can we see anything that we can take out? Honestly, the answer is no. We see a tan here of 5x plus 2, but we have a secant squared 5x plus 2, so we can't pull those out. And here, there's nothing here that can be pulled out, so we leave everything alone. Alright, that's the end of this video, folks. It was a really short one. Hopefully you understand how to take the derivative of tan. Have a good night.